Good day, grade 11 learners. Welcome to Life Sciences lesson. My name is Ntombi Dladla. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Let's quickly look into it. Okay, grade 11s. Today's topic are the environmental factors which affect the rate of photosynthesis, and we'll also be looking into the greenhouses. Remember, we are continuing with our chapter of photosynthesis. Now let's quickly look into it. Now, before we can look into the factors that are affecting the rate of photosynthesis, we need to remind ourselves on the definition of photosynthesis. By the way, what is meant by photosynthesis? What are we referring to when we talk of photosynthesis? Remember that photosynthesis is a process whereby green plants, all the green plants are using sunlight, which is coming from the sun, to produce nutrients by the use of using carbon dioxide as well as as water. And then that is the process of photosynthesis. In other words, when we talk of photosynthesis, we are simply talking about the process whereby all the green plants, with the aid of of chlorophyll, are using sunlight to produce organic food or to produce nutrients, using using carbon dioxide as well as water. Now let us look into the factors which are affecting the rate of photosynthesis. How is the rate of photosynthesis being affected by different factors? Now the rate of photosynthesis can differ depending on the concentration of the raw materials. Now when we talk of the raw materials, we are simply talking about those factors which are affecting the rate of photosynthesis. Now the raw materials can either slow down the process of photosynthesis, or they can even fasten it up. It depends on the availability or on the amount of those raw materials. Now let us look into those raw materials which can affect the rate or the process of photosynthesis. The first one will be the light intensity, or the intensity of light. The second factor that may affect or can contribute in the process of photosynthesis will be the concentration or the amount of carbon dioxide. So carbon dioxide can also play a very crucial role in the rate of photosynthesis, depending whether it is in its optimum amount or it is lower. It will depend. And then the other factor that may or can contribute or can influence the rate of photosynthesis will be temperature. Now let us quickly unpack all these factors one by one. Now let us now look into the rate of light intensity, on how light intensity can affect the rate of photosynthesis. Now let us look into this graph. This graph is talking about the light intensity versus the rate of temperature. I mean the rate of photosynthesis. Now what is happening when we look into this graph, we can see now that when the light intensity is low, what is happening with the rate of photosynthesis? The rate of photosynthesis is also low. However, as the light intensity increases, what is happening with the rate of photosynthesis? The rate of photosynthesis also increases. So the rate of photosynthesis will increase up to its optimum value, up to its optimum point. So what is happening now? It means that after this temperature has increased up to its optimum, in this instance we can say 3 is the optimum value. It means that it can increase rapidly, so but after it has increased up to its optimum, it means that now it can now remain constant. Why is it remaining constant? It is because now as the light intensity increases above 3, as it increases above 3, it increases above 3, it means now that the rate of photosynthesis will no longer increase any further, but it will do what? It will remain constant. So this shows us that when the light is low, what is happening with the rate of photosynthesis? The rate of photosynthesis is also low. The light intensity is low, maybe it's at 0, is at 1, so the rate of photosynthesis is also low. However, as the light increases, what is happening? The light increases, what is happening with the rate of photosynthesis? It is also increasing. So it means that it will increase up to a certain point, and that point we refer to it as what? As the optimal point. Now what is happening? As soon as it gets into its optimum value, or as it gets onto its optimum amount, what is going to happen with the rate of what? Of photosynthesis? It is now going to do what? It is now going to be constant. In other words, if it increases above the optimum, then the rate of photosynthesis will remain constant. As you can see now that our graph, or our line graph, is now constant. It does not increase or does not decrease, meaning that it increases up to its optimum value, or up to its optimum amount. So this is how the light intensity affects or influence what? The rate of temperature. Now let us look into the second factor. Remember, we said the second factor will be the concentration of what? Of carbon dioxide. Now this graph does not differ from the previous graph, whereby we have seen the light intensity versus the rate of temperature. Same applies here with what? With the concentration of carbon dioxide. On this graph, we are having the rate of photosynthesis versus what? The concentration of carbon dioxide. So what is happening when the amount of carbon dioxide is low? When the amount of carbon dioxide is low, what is happening now with our rate of photosynthesis? The rate of photosynthesis also remains low. However, when the rate or the concentration of carbon dioxide starts to do what? To increase. When it starts to increase, what is happening again with the rate of photosynthesis? Can you see the rate of carbon dioxide is, or the concentration of carbon dioxide is increasing? So what is happening with the rate of photosynthesis? The rate of photosynthesis also increases. Why? Because the concentration of carbon dioxide increases. So it will increase, the rate of photosynthesis will increase up to the optimum amount of what now? Of carbon dioxide. This means if it will increase rapidly up until it gets to its optimum amount. So the optimum amount here in this instance will be 3. Now what is going to happen now? If the concentration of oxygen exceeds the optimum, which maybe might be above 3, 3.3, 3.5, 4, 5, it means now that the rate of of photosynthesis will no longer increase, but it will also remain constant. So let us look into our mini notes that when the carbon dioxide concentration is low, what is going to happen with the rate of photosynthesis? The rate of photosynthesis will also be low. And then when the rate of the concentration of what? Of carbon dioxide increases, what is happening now with the rate of photosynthesis? The rate of photosynthesis also increases. So that will only happen up to a certain point. What is the point? The certain point is that optimum amount. So it will increase up to that certain point. After that certain point, and then the level of what? Of photosynthesis will remain the same, because now the carbon dioxide is now exceeding the certain point, or the optimum amount, which is 3 in this instance. I am not saying every time the concentration of carbon dioxide will be 1, 2, or 3, but looking into the graph that we are given here, the optimum will be 3. So it means that it will increase up to 3, above 3, and then the rate of photosynthesis will always remain constant. So this is what is it is explaining that when the optimum amount of carbon dioxide is reached, what is going to happen? There will be that rapid increase. However, if the concentration of carbon dioxide is now higher than what? Is now higher than 3, which is the optimum. That is going to happen. What is going to happen? The rate of photosynthesis will now remain constant. I think I've explained all these things on the previous slide. Now, why is this happening? This is because during the light independent phase, remember when we talk of the light independent phase, we are simply talking about what? The dark phase of what? Of photosynthesis. It means that during the dark phase, the photosynthesis cannot take place more rapidly than what it does during when the concentration of carbon dioxide has reached its optimum level. It means that during dark phase or during light independent, remember light independent, it means that this phase does not require sunlight to happen. So that's why all this optimum value is reached. So it means that if it has been reached, it means that photosynthesis cannot take place more and more quickly during what? During dark phase, as compared to what? To the optimum value of what? Of carbon dioxide during the dark phase stage. Now, the last effect of the factors that are influencing photosynthesis will be what? Temperature. Now, temperature is the last factor which contributes or has an influence in the rate of what? Of photosynthesis. Now, let us look into this graph. What is happening now? If temperature or if the temperatures are low, what does that mean? It means that the rate of photosynthesis will also be low. However, if the temperature now starts to do what? To increase, it increases, and then what is happening when we look into our y-axis? What is happening as the value as the temperature increase? As temperatures increase, what happens to the rate of photosynthesis? The rate of photosynthesis also increase, and then it increases up to its optimum value. Now, the optimum value of temperature for the process of photosynthesis to take place is always 25 degrees Celsius. Now, in other words, at 3 there, that's where we are having our 25 degrees Celsius, meaning that the 25 degrees Celsius is the optimum. It is the optimum amount of what? Of temperature. In other words, the rate of photosynthesis will increase rapidly up to what? Up to 25 degrees Celsius. But when the temperatures are low, what is happening with the rate of photosynthesis? The rate of photosynthesis is also low. But as it increases, what is happening with the rate of photosynthesis? It is also increasing. Now, what is happening? It will increase up to its optimum amount. What is the optimum amount? I said it will be 25 degrees Celsius. Now, if the temperature exceeds 25 degrees Celsius, maybe 27 or 28 or 30, it means that the temperature now is more than what is required by the process of photosynthesis. What does that mean? It means now that the process of photosynthesis will do what? Will decrease. Why is it decreasing? Because now it has reached what? The optimum. If it goes above 25, what is going to happen now with the temperature, the rate of photosynthesis? The rate of photosynthesis will also decrease. Why is it decreasing? Remember, the process of photosynthesis is made possible by what? By the enzymes. By the enzymes. And we know that enzymes need a certain temperature for them to be what? To be active. Now, if the temperature is above what is required, it means that these enzymes are going to become inactive. And then if they become inactive, it means now that the process of photosynthesis will no longer be able to do what? To take place. Hence, the rate of photosynthesis will do what? Will drop because of the enzymes being denatured, because of the enzymes being inactive By what? By the high temperatures. It only needs up to 25 degrees Celsius, but anything above that, it will make the enzymes that are making the process of photosynthesis to take place, it will make them to become denatured. It will make them to be inactive. So if enzymes are inactive, it means that process of photosynthesis is no longer taking place. And if the process of photosynthesis is no longer taking place, what is going to happen now with the rate of photosynthesis? The rate of photosynthesis will therefore drop. Now, this is explaining what I've just explained, that when the temperature is at its optimum, and then the rate of photosynthesis will increase up to that optimum value, will reach its maximum point. However, if now it's above 3, if now it's above 25 degrees Celsius, it means now that the temperatures are very, very high. So what does that mean? It means that the higher the temperature will do what? Will cause the enzymes to do what? To become denatured or to become inactive. So if our enzymes are no longer active, what does that mean with the process of photosynthesis? It will make the process of photosynthesis to do what? To stop. Why is it stopping? Because our enzymes have become inactive. They became denatured. So if process of photosynthesis stops, what does that mean with the rate of photosynthesis? It means that the rate of photosynthesis will also drop due to what? To a high temperatures. The higher temperatures are the ones which are above the optimum amount. So this is what it explains. This graph shows that there will be a increase as well as the decrease depending on the amount of what? Of temperature. I think it has explained all the factors that are affecting the process or the rate of temperature. Do you have any questions before I can pose my questions, grade 11s, based on what I've just explained? Okay. If there's none, I can see you are looking at your friends. But if you need something that you want me to explain or to clarify, please just raise up a hand or just talk. Yes. Hi. So do you allow me to continue? Okay. Now, because you do not have any questions for me, I do have questions for you. I will give you some time to read into the extract and then answer the questions which are based on that. Let me quickly read the story for you, and then you'll be able to answer that. What we are given on activity 1, we are given a graph, but the graph is explained on our right-hand side, that the scientists set up an apparatus to investigate the effect of temperature, the effect of light intensity, and the effect of carbon dioxide concentrations on plant growth. Now, using this apparatus, they could control each factor. So what are the factors? These are the factors. Now, the scientists set different temperatures. They set the carbon dioxide concentrations, and then they also set light intensity for 4 different groups of what? Of lettuce plants. Now, the average mass of lettuce plants serves as an indication of the rate of photosynthesis. In other words, this average mass serves as what? As indication for the rate of what? Of photosynthesis. So what we are given on the graph here, we are given the graph which shows the light intensity in arbitrary units versus the mass of the lettuce plants, and then they were measured with what? With grams. And then we are just told that the mass of lettuce represents what? The rate of photosynthesis. Now let's look into the first question. What is the influence of light intensity on the average mass of the lettuce plants? I am giving you the chance to answer, grade 11s. What is the influence of the light intensity on the average mass of the lattice. What is the influence of the light intensity? So our light intensity starts from 0 up to 10. So what is the influence of this light intensity over what? Over the mass or the average mass of what? Of lattice. What is happening with light intensity, and that contributes to whatever you see on our mass of lattice. Anyone who wants to try? You need to study the graph. What is happening? What is happening with light intensity? As light intensity increases, what is happening with the mass of the lattice? Yes, I can see a hand there, but I don't. Yes, Sissy. Excellent. When the light intensity increases, can you see from 0 to 2, the light intensity increases. What is happening with the mass of the lattice? It increases. As it increases to 4, what is happening to the mass of the lattice? It also increases. As it increases, can you see? That is a very brilliant answer. As the light intensity increases, the mass of the lattice also increases. Very, very good. I like that. So the rate of photosynthesis increases as the light intensity increases. So remember that the mass of lattice indicates the rate of photosynthesis. So therefore the rate of mass of lattice also increases. So it means that as light intensity increases, the rate of photosynthesis increases. Very good. The second question, name 2 limiting factors that influence the rate of photosynthesis as the light intensity increases. Now, apart from the light intensity, name other 2 influencing factors. Looking into our graph, so what other factors do we have? We can also look into these. What other factors do we have? What other factors do we have? Yes, boy at the front. Very, very good. CO2. What is CO2, by the way? What is CO2? Before you get too excited, what is CO2? Carbon dioxide. High five. So carbon dioxide as well as temperature. Yo, this is a very brilliant class. Thank you so much. So carbon dioxide as well as temperature. Let us look into the other question. How were the scientists able to increase the rate of photosynthesis to its maximum level? So how were the scientists able to increase the rate of photosynthesis to its maximum level? So there is the maximum level. So how were the scientists able to increase the rate of photosynthesis to its maximum level? Let's go. I want a different hand. She answered the other question. I want a different voice now. Yes. You, boy, who's pointing the other one? Yes. Aha, I got you. Yes. Or can't you see the question? The question says, how were scientists able to increase the rate of photosynthesis to the maximum level? So the maximum level is here. So how were the scientists able to increase the rate of photosynthesis to that maximum level? And the answer is there. The answer is looking at you. By increasing the what? The light intensity. the temperature from what to what? At the beginning, the temperature was? You can't see. Okay, at the beginning, the temperature was 15 degrees Celsius. And then it was now increased to what? To 25 degrees Celsius. Can you see that? Yeah, you are correct when you say they were able to increase the temperature from 15 to 25 degrees Celsius. And what else were they able to increase? Yes, the what? No, not light intensity, but what? Remember, we are here at the optimum amounts. So you are saying temperature was increased, and what else was increased? Carbon dioxide. To what amount? To 4%. Excellent. That is very, very good. So in other words, they were able to increase the level or the concentration of carbon dioxide to 4%. The other factor that they were able to increase was temperature or light intensity from 15 to 25 degrees Celsius. That is very, very good. I like you guys. And then we move on. What will happen to the rate of photosynthesis if temperature raised beyond 35 degrees Celsius? Remember, we said the optimum was now 25 degrees Celsius. So what will happen to the rate of photosynthesis if temperature was raised beyond 35 degrees Celsius? Yes. Yes, I can see the hand in front here. Yes, baby girl. Very good. So what will make enzymes to be inactive? Temperature. When it's low. When temperature is low, it will make the enzymes to denature. Perfect. When the temperature is higher than the optimum, remember now it's in 35 degrees Celsius, it will make the enzymes to become denature. So that's why the rate of temperature will do what? Will stop or will never happen again. So the answer is that the rate of photosynthesis will decrease drastically because of the high temperatures. And then give a reason for your answer. You've already explained that because the higher temperature denature the enzymes, or the enzymes become inactive. Happy? Can I move on? Good. Activity 2. The diagram below shows the apparatus that was used to investigate the rate of photosynthesis in a submerged plant. So this is our submerged plant. The light intensity to which the plant is subjected was decreased at irregular intervals by moving the light source away from the plant. So this is the light intensity which is coming from the lamp. Now, the average number of bubbles per minute was counted and recorded for each distance. So these are the average number of bubbles which were counted per minute. And then this is the distance of lamp towards what? Towards our submerged plant. Now, the first question says, what is the aim of this investigation? What is the aim of this investigation? Remember, this investigation, we are having the test tube, and then in the test tube, we are seeing the bubbles there. Those bubbles are caused by what? Oxygen, and then there's a beaker containing water, inverted funnel, water, plant photosynthesizing. So what is the aim of this investigation? Anyone who wants to try? Anyone? Or do you want me to rescue? I know. Okay, so the aim of this investigation is to determine if oxygen, can you see, this is a leading weight, is to determine if oxygen is released during photosynthesis. So that is the aim of this investigation. Now, the second question says, name the gas released by the plant. What is the gas that is released by the plant? It's also the oxygen. Very good. So oxygen is the name of the gas that is released. Now, describe the test to verify your answer in the previous question. You said the released gas is oxygen. Now describe the test to verify the answer that, of course, this is oxygen. Yes? The previous question was about the gas being released, and you said the gas is oxygen. Am I correct? That's what you said, and we all agreed that the released gas is oxygen. Now the follow-up question says, describe a test to verify your answer in the previous question. Describe the test to verify that oxygen was released. Do you also want to be rescued on this one? Or anyone who wants to try? I can forgive you because we did not do the practical investigation on this part, and then let me quickly give you the answer. Now, to verify that oxygen was released, now how am I describing the test? It is that I will immerse a glowing splint into the test tube. I will immerse the glowing splint into the test tube where gas is collected. After immerse that that splint, what is going to happen now? If the splint bursts into flame, it shows that oxygen is present. So the test is that when we immerse the splint into this test tube that is has bubbles or gases, if it bursts to give us flames, it means that oxygen is present in that funnel. Now the second question, describe the relationship between the gas released and the light intensity. Describe the relationship between the gas released and the light intensity. What is the relationship between these two variables? Let me clean them. What is happening when the lamp is closer, and what is happening with the number of bubbles? What is happening when the lamp is far away, maybe 80 centimeters away from the plant? What is happening with the number of bubbles? That is the relationship I want you to explain, looking into both variables. Anyone? I can see hands. There's always one hand. Okay, I can see another hand. When the light, yes. Very good. When the light intensity decreases, what is happening with the number of bubbles? They also increase. And there's another way, or who can put it? Ne? There's another way. If the, yes, I can see a hand. When the light intensity increases, meaning that is closer to the plant, what happens to the number of bubbles? Decrease. Increase. Yes. So that is very, very true. When the light intensity decreases, also the number of bubbles decreases. And then when the light intensity increases, the number of bubbles also increase. And then name 2 other environmental factors except light intensity, which you think will change the rate of bubble production. Yes. Yes, baby girl. Temperature, I agree. And what else? Because they want 2 other environmental factors. Temperature and carbon dioxide. Very, very good. So it's temperature and the concentration of carbon dioxide. Very, very good. Now let us continue with our lesson. So we'll look into the greenhouses now. So who can tell me what is meant by a greenhouse? What is a greenhouse? Or what are the greenhouses? What are the greenhouses? Yeah, yes, baby girl. What is a greenhouse or what are the greenhouses? Is the transparent house, which does what? Yes. Yes. Okay. Yes. Greenhouses are these structures which are built specifically to do what? To grow plants under a controlled environment. Now, mostly our greenhouses are made up with transparent or translucent structures, mainly glasses or your transparent plastic. And then why are they built in such in those structures? So that they are able to do what? To grow plants in them. So this is just an example of how a greenhouse looks like. So when you look into the structure, you can see that it is made up of transparent glasses. It can also be made up of transparent thick plastics which cannot maybe get broken easily. So this is the structure. It is made up of transparent, and then inside the house, that's where we are growing different plants under a controlled environment. Now, let us look into the greenhouse as a whole. So, what is the purpose? What is the aim of the greenhouse? Or what are the purposes of the greenhouses? The greenhouses are there to do what? To maintain the optimum levels of all the factors that are contributing to the rate of photosynthesis. And then remember those factors, we've got carbon dioxide, we've got temperature, as well as light intensity. Now, the main purpose of greenhouse is to maintain all these factors at their optimal levels so that plants can grow very, very well. Now, let us look into the first factor now, which is light. How does light passes into the what? Into the greenhouse. Now, the light passes through the transparent structures of what? Of the greenhouse. For the fact that it is transparent, it means that the light, let me write here, it means that if this is our greenhouse, for the fact that it is transparent, it means that the light can be able to do what? To pass through the transparent structure. And then the artificial light will also be used now by what? By these plants inside the what? Inside the greenhouse for the what? For the process of photosynthesis to do what? To take place for a longer period of time. Meaning that the sunlight is able to pass through the transparent structure of the greenhouse, and then the artificial sunlight or the artificial light can be used by plant for the process of photosynthesis to take place. Secondly, carbon dioxide. How does carbon dioxide get into the greenhouse? Now, what is happening? Remember, in the atmosphere, we are having our carbon dioxide. And if this is our greenhouse, meaning that through the passage, through the pores, carbon dioxide can be able to pass through. However, much of carbon dioxide can be pumped into the what? Into the greenhouse. In other words, the level of carbon dioxide inside the greenhouse will increase. And other form of increasing the level of carbon dioxide inside the greenhouse is by burning gas lamps inside the greenhouse. In that regards, the level of carbon dioxide will also increase inside the greenhouse, and that will enable the process of photosynthesis to take place. And then the last factor, which is temperature. The temperature can be kept at its optimum level by using the heating systems. If maybe we are having those cold days, it means that they can put the heaters inside what? Inside the greenhouse, so that the temperature levels can can increase. But in cold days, they can also use what? The cooling system inside the what? Inside the house. And then we know that most of the time the cooling systems that we are using will be our fans. So they can also use the fan to do what? To cool down or to decrease the rate of temperature, so that it is always at its optimum level for the process of photosynthesis to be able to take place. Now, how does light come in the greenhouse, in greenhouses? So in order to provide light, the greenhouse needs some way for the light to do what? To come in. Now, because the structure is made up of transparent glasses, meaning that it is able to do what? To allow the light to pass through, to enter into the house, because it is made up of what? Of transparent glasses or clear plastics. And then this gives the plants which are inside the greenhouses a maximum access towards what? Towards sunlight. So we can never build the greenhouses with what? With dark structures, dark plastics. It means that there won't be any sunlight that will be able to pass through. So that is why it is made up of transparent glasses. So how heat is absorbed by the plants. So when the light comes through the glasses or the walls of the glasses of the greenhouses, it is absorbed by the plants. So this is our sunlight, and then it passes through, and then it will be absorbed by what? By our plants which are in the greenhouse. It will also be absorbed by what? By the ground, maybe the soil, and it will also be absorbed by anything that is inside the greenhouse. And now what is going to happen with this light? This light, as soon as it gets into the greenhouse, it is now going to be converted into the infrared energy. What is an infrared energy? Infrared energy is the heat energy. So when it is outside the greenhouse, we are not referring to it as what? As infrared energy. But as soon as it reaches everything that is inside the greenhouse, it will now be converted into the heat energy. So can you see now that we are having our sun energy that is passing through the transparent glasses, and then it gets inside the what? The greenhouse, and everything that is inside the greenhouse will now absorb that heat, sun energy. And then that sun energy will be automatically converted into the infrared energy, and infrared energy is the heat energy. So this is how this conversion is being made possible. Now, what is happening when the heat gets trapped inside the greenhouse? So what is going to happen as soon as it has been converted into the infrared energy? Remember, the infrared energy is our heat energy. Now, the wave lengths are no longer the same. When it is outside, when it is the energy from the sun, can you see the wavelengths are shorter as compared to the wavelength when it has now been converted into what? Into the infrared energy. So when it's from the sun, can you see the heat waves? I mean the heat the waves, the wavelength are small. Can you see they are smaller as compared to the converted energy, which is now infrared energy? As soon as it hits the soil, the plants and everything, it is now converted into what? Into an infrared energy. Now look at the wavelength. The wavelength here on the red parts are not the same as the wavelength on the blue parts. When it's outside, the wavelengths are shorter, and then when it's inside, or when it is now converted into the infrared energy, the wavelengths are now what? Are now bigger as compared to the wavelength when it was on the sunlight. Why is it that so? Why are these wavelengths of the infrared energy longer or bigger as compared to the wavelength of sunlight? It is because when the wavelengths are longer or bigger, they won't be able to do what? To escape. The heat won't be easily escape what? The greenhouse. In other words, much of the heat will remain inside what? Inside the greenhouse. And that will increase what? The temperature inside the what? Inside the greenhouse, because more heat has been absorbed. It was not able to do what? To escape the what? The greenhouse to the atmosphere because of this long wavelength. So that is why much of the heat remains inside what? The greenhouse. So this is what this slide is explaining. So why is how is greenhouse working? How are the greenhouses working? Number one, they are there to promote the rate of photosynthesis. How so? All the light and warmth temperatures give plants an ample access to the sunlight, which has been absorbed by all these plants, and then the temperatures they need for what? For growth. In other words, the greenhouse are very, very important for the process of what? Of photosynthesis to take place, because all the temperature, all the heat, and all the carbon dioxide that is needed for the process of photosynthesis to take place will be able to take place because of them greenhouse effects. Now, let us look into this question. A tomato farmer was able to produce crops in a greenhouse which were heated to between 15 degrees Celsius and 22 degrees Celsius. In addition, the carbon dioxide level was increased from the normal 0.03% to 0.1%. Now, the first question says, state one way in which the farmer could have enriched the air inside the greenhouse with carbon dioxide without burning any fuel. So that is the question. State one way in which the farmer could have enriched the air inside the greenhouse with carbon dioxide without burning any fuel. Yes, let's hear. I'm waiting for the answer, grade 11s. how could the farmer have enriched the air inside the greenhouse with carbon dioxide without burning any fuel? We know that burning fuel also increases the concentration of carbon dioxide. Without this burning of fuel, what else could the farmer have done to increase the concentration of carbon dioxide in the air? Yes, baby girl. Yes, Dali. You, the one who's laughing. Yes, 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 boy. Yes. 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 And what else? Very good, Fana. It's just that you are far away. I would have given you so many chocolates. Yes. And what else? That is the correct one. And what else? Yes. Okay, let's quickly look into other options. And then pump, very good. That was, okay. I'm sorry because I've just shown all the answers. To pump carbon dioxide from the tanks into the greenhouse, it's what our boy gave us. That is the first one. And then the other way to increase the level or the concentration of carbon dioxide inside the greenhouse is to add sodium bicarbonate to the soil. Remember, sodium bicarbonate has what? Has carbon dioxide. And then the last one is to add organic material that can decompose. Explain how increasing the level of oxygen up to 0.1% can lead to an increased production of tomatoes. No problem. Thank you so much. Thank you so much. So this takes us to the end of our lesson. Until we meet next time. Bye-bye.